Good morning. Today we'll be working on lesson 3.1c, where we're going to be writing equations that represent real-world situations. So it's a continuation of our first two lessons, 3.1a and 3.1b. Let's take a look here. We're going to be doing our review up in the top left-hand corner of your paper. We got pause problems and take it to the show, of course. We got 1 through 16 and some guided work, and then we've got an early finishers challenge here. So really, we're going to spend a lot of time working together today, and those of you who get done with a quiz and stuff a little earlier, there's a challenge there, but we haven't got as much independent work as one would normally have. So let's go ahead and get started with the review. There are no decimals today. Just take about a maximum of 5 minutes to see how far you can get through working on these problems. All right, here's how I did. You multiply 123 by 42. Did you remember to put the 0 down when you got to the 40s column? Because that's really 40 times 3. So if you did that, you'd end up with 5,166. And then if you divide it over here, 43 doesn't go into 20. It doesn't go into 2. It doesn't go into 24. But it goes into 245 times. That's 215. When you subtract, you have 25 left. Bring down the 8, you've got 258. Goes in there 6 times. And it's exactly 6 times. So you end up with a two-step division problem. These ones down here, 4 more than the number 10. That'd be n plus 4 equals 10. 4 times the number decreased by 4 is 16. There's the 4n minus 4 is 16. 3 times the sum of a number and 3. There's that parentheses. So it's 3 times n plus 3 equals 12. And then this one here, slide this down just a touch. Oh, it won't let me. There it goes. The quotient of a number and 3. So here's the number. A number and 3 equals 6. Alrighty, there you go. And you are ready for your video. Good luck. Have fun tonight. Hey Valley Middle, welcome back to another math video. Tonight we're going to be continuing our work with equations. Before we do that, I'll start off with a trivia question here. Here are two of my favorite TV shows growing up. This was on from 4:30 to 5. This was on from 5 to 5:30. I'd get off the bus about 4:15. So it was snack, and then these two shows was my after-school routine. Can you name either of them? Be back with the answer to that after instruction tonight. Officially, our target. I can write an algebraic equation to represent a real-world situation. Let's take a look at this. So our goal tonight is to write an algebraic equation. I know we're all going to be tempted to solve it, and solving problems is easier than writing algebraic equations by a long stretch. So let's just go through this problem. So Casey and Tara raked a lot of leaves this weekend. They raked a total of 100 minutes. Casey raked 40 minutes. Write an algebraic equation that would help you figure out how many minutes Tara raked. Well, when we think about it, solving it, that's easy. Kind of the mid-level thing is choosing the correct equation to match this situation from a list, such as a multiple choice test. The most challenging is actually writing the equation. Let's take a closer look at how I would like you to go about doing that in these situations. You got to start thinking about, first of all, what you're trying to do. In this situation, we're really trying to figure out how many minutes Tara raked. That's what we're trying to figure out. The second thing we're trying to figure out here is what variable you're going to use. So if you're using it for the amount Tara raked, I'm going to use t for Tara. So I've chosen my variable. The third thing you need to do is just solve the dumb problem and figure out what it is. So 100 minutes total minus Casey's 40 minutes would equal 60 Tara. So now I've got my answers figured out. I have the problem figured out. I just have to write the equation. So let's look at that more carefully. So I solved it with subtraction, so I'm going to use the opposite operation to write it. So I'm going to turn that around, I'm going to use addition to write the equation. So I'll use t for my variable. So here's the amount Tara raked plus the amount Casey raked, and here's the total. Notice that the variable and the number on one side of an equal sign balance out the solution on the other. You always want the variable over here with the operation. You don't want the variable to stand alone. In other words, you don't want 60 plus 40 equals t. You want the variable with the operation. The operation means multiplication, division, addition, or subtraction. So, of course, you can check your answer to make sure it works right. You substitute in Tara's answer. Remember, you solved it for 60 minutes. 60 minutes plus 40 minutes equals 100 minutes. Or Tara's minutes plus Casey's minutes equal a total of 100 minutes. So using this process, we can solve a lot of problems and write a lot of equations. So let's just try to use the process. And what I did was I put a little cheat sheet up here. These are the questions I ask myself. First of all, what are we trying to figure out? I choose a variable. I figure out the answer. I solve the dumb problem. And then if I solved it with subtraction, I'm going to write an addition equation. If I solved it with addition, I'm going to write a subtraction equation, and so on and so on. So the opposite operation is what you use to write it with. So multiplication, solve with multiplication, write with division. Solve with division, write with multiplication. So I'll have this little cheat sheet available there. So let's look at 2 more problems, and I'll have you try some on your own. Chris gets 3 new video games. Now he has a total of 10 video games. How many games do you have to begin with? Well, we can solve that problem so easy. So let's just kind of follow the system. What are we trying to figure out? Well, we're trying to figure out how many games he begins with. Okay, the next one. Choose a variable. I'm going to use G for the games he begins with. It makes sense. Okay, solve the dumb problem. Well, 10 games minus 3 games equals 7 games. That's what he had to begin with, 7 games. So now I got the answer down. I solved that with subtraction, so I'm going to write it with addition. So here's the games he started with. I'm going to add the 3 new games, and he has a total of 10 games. When you think about it in this way and breaking it down, pretty soon these steps become automatic, and you can do this. Very difficult target. Let's take a look at another one. This isn't your turn yet. I'm going to do one more, I decided. In 2 years, Sydney will be 14 years old. How old is she right now? All right, well, let's think about that. What are we trying to figure out? Trying to figure out how old Sid is right now. Okay. What variable do you want to use? How about S for Sid's age now? All right, solve the dumb problem. Well, it's going to be 14 years minus 2 years is 12 years. She's 12 years old right now. So I solved it with subtraction, so I'm going to write again with addition. So Sid's age now plus 2 more years is going to make 14 years. Situation, or the equation makes sense. It matches the story. And did you notice how I said Sid's age now instead of just saying S plus 2? What does S mean? You have to say or think that so that you understand if you had your equation right. All right, I got 2 you try problems here. Pause problems, whatever you want to call it. Why don't you go ahead and give this a shot? I've got the questions up here, and you can take a look at those. Go ahead. Okay, Raekwon has 24 pieces of candy, gives them all the way to some friends. Each friend gets 4 pieces. How many friends does he give candy to? All right, Raekwon was one of my favorite students from a few years back. All right, write an equation that represents the situation. All right, well, we're trying to figure out how many friends he had because he gave his candy away. They each got 4 pieces. We're going to use F for friends. That's the variable I chose. It made sense. And let's solve the dumb problem. Well, if you took 24 pieces of candy and you divided it, if you took 24 pieces of candy, each friend got 4. 24 divided by 4 would be a total of 6 friends. So let's put this together and see if this makes sense. 4 pieces of candy times the number of friends he has, or 6, equals 24. Here was a division. We solved with division. We write with multiplication. All right, let's try another one. Go ahead and pause the video and try this. Making cookies, she wants to make sure that 10 people each get 3 cookies. How many cookies does she need to make? All right, let's figure this out. We have to write an equation, represent that situation. So we're trying to figure out how many cookies to make. And for variable, hey, let's use C for cookie. That makes sense to me. All right, now solve the dumb problem. Well, if 3 cookies for 10 people would be 30 cookies total. Okay, so we solved the multiplication, so this one's going to be written with division. So if we take the total number of cookies, we divide it by the 10 people, they'll each get the 3 cookies. So total cookies divided by 10 people, 3 cookies each. It makes sense. Again, I'm not saying C divided by 10, I'm saying what that C represents. That's the key. More important than any of the other steps is inserting what the meaning for that variable is. That's especially important when you enter into a situation where you've got a multiple choice question and you've got 4 answers, and they all look good. If you say what the variable means as you go through there, you'll help understand and eliminate some just ridiculous possibilities. All right, here we go. Again, I know you're going to be tempted to solve these. That's why I've got the arrows pointing down here. You're just going to write equations for these situations. If you need to solve it to figure out which operation to use to write the equation, that's just fine. But I'm not interested in the solution. I'm interested in the equation. First problem, there are 48 rooms in a hotel. 30 of them are occupied. How many rooms are vacant? There are 28 kids in math class. I put them into 7 different groups. How many kids are in each different group? Go ahead and do that. And we'll look at the trivia question. From my youth, this was Hogan's Heroes. Very funny show. There were a number of seasons, I think 5 seasons of it. This was Gilligan's Island. Another very funny show. You may have seen this one around. I think this one is on some of the old channels too, but Gilligan's Island has lasted a little bit longer. These guys are all castaways on an island. These guys, these people here, these 5 gentlemen, are all prisoners in a prisoner of war camp in Germany. They're both sitcoms, which means they are not funny shows. They were just fun. All right, take care. Have a good day. Hey folks, welcome back. I think the best way to master this target is just to do a bunch of problems together. So really that's what we're going to be doing today. If you remember right, we're going to do 16 of them together. And then those of you who find this very easy and are able to get through the quiz in a hurry, you can come back and look at some of the early finisher independent challenge problems I have at the end. But let's just get started with a little bit of a review here. Think about, number 1, what are you trying to figure out in the question? What is it asking for? Choose a variable, figure out or solve the stupid problem, and then use the opposite operation to write it. So if you solved it with subtraction, write with addition. Solved it with addition, write with subtraction. Solved with multiplication, write a division equation. If you solve with division, write a multiplication equation. So our record of learning is just going to be lots of word problems. So let's get started. You're going to number 1 through 16, and it's going to be a fairly guided lesson. I just think it takes repetition on this one here. All right. Marion bought 41 gummy worms at the candy store. His friend Brooke also bought some gummy worms. When they counted them, all of them together, Marlon and Brooke had 75 worms. Which equation, when solved, will show how many gummy worms Brooke bought? Okay, well, to solve that, I would go 75 minus 41. So if I go 75 minus 41, that's a subtraction thing. Do you notice how I didn't even solve it? I just set it up as like, hey, I would solve it with subtraction, so I'm going to write with addition. So there are 2 addition equations here. Now let's just put them in and see if it works. So 41 gummy worms plus the ones that Brooke brought equal 34. Well, that sounds pretty good. This one doesn't make any sense. It's division, and the variable's by itself. Let's take a look at this one. 41 gummy worms plus the ones that Brooke bought equals 75. Well, wait a minute. This one doesn't make any sense, does it? 41 gummy worms plus the ones that Brooke bought are 34? No, I almost got tricked by taking the first addition equation there. You've got to read all of them and make sure they make sense. This one, though formatted properly, doesn't make sense. I mean, how could you buy gummy worms and actually have less? Okay. C is the correct answer for this one. So you could just write C, or let's have you write the equation. 41 plus W equals 75. Let's have you write the equation instead of the letter. All right, the next one here. Lacey put baseball cards in her baseball card collection into a binder. She split the cards evenly among 7 pages. There are 10 cards on each page. Which equation, when solved, will tell how many baseball cards Lacey has? So let's think about it. I'll give you just a few seconds to think about these. You don't have to pause. I'll just wait. Well, to figure out how many cards she has, wouldn't you go 7 times 10? So if you're solving that with a multiplication, it would have to be a division, and there's only one division one here. So let's just see if it makes sense. Here's her card collection. She divided among 7 pages, and there's 10 cards in each page. Boy, that sure makes sense to me. Let's just see how silly some of these other ones makes sound. Here's her card collection. She subtracts 7 cards and she has 10. What? No. 10 cards, and we're going to take away, we're going to subtract her collection, and there's 7 left over. What? 7 pages times the number of cards in her collection equals 70? What? Did you drink your chemistry set? There's something wrong with you. No, I'm teasing. Yeah, they just don't make sense. And the reason why they don't make sense is because I'm putting in what that variable means, and that's why it's so important to establish that. All right, let's move a little faster this time here. Here's a problem. Go ahead and try this one. Reagan had a pile of notebook paper on her desk. She used 28 sheets for her homework and had 38 sheets left. Which equation, when solved, will tell us how many sheets of paper were in the pile? Well, I'd certainly subtract it, right? I'd do 38 minus, I would do 38 plus 28 to figure out how many she started with. So I'm starting it with addition, so I'm looking for subtraction equation. So here's the subtraction equation. Let's see if it makes sense. She had some pieces of paper. She used 28, and there are 38 left over. Boy, that makes sense. Bam. B. P minus 28 equals 38. All right. I accept the answers in there. I kind of forgot. All right, number 4. Danelle bought 5 packages of light bulbs. She bought 40 bulbs in all. Which equation will solve will tell how many light bulbs were in each package? Take a couple of minutes. Well, I would divide this, right? I go 40 divided by 5. So that's division. So the opposite is multiplication. Let's check this one out, see if it makes sense. 5 bulbs in a package times B packages, or times 8 packages, equals 40. Yeah, there we go. Boom, A. Try this one. Shelby put her baseball card collection into a binder. She split the cards evenly among 3 pages. There are 14 cards on each page. Which equation, when solved, will tell how many baseball cards Shelby has? Well, again, I would take the 14 cards and multiply it by the 3 pages, and you get 42. So if I multiply to solve it, I'm going to write it with the division. There's 2 division problems. Let's see. 3 divided by 14 equals the card she started out with. What? No. Plus the variable's off by itself. That's not even formatted properly. The number of cards in her collection divided by 3 pages, 14 cards on each page. Bam! C. So we got A and C on that page there. All right, let's keep rolling here. Downtown, 7 rooms are occupied, the rest are empty. There are 50 rooms in the hotel. Which equation, when solved, will show how many empty rooms there are in the hotel? Go ahead and think about it. All right, well, there's 50 rooms and 7 are occupied, so I'd go 50 minus 7. So that's subtraction. So I'm looking for an addition one. So let's see. Here's only one addition one. Let's see if it makes sense. 7 rooms occupied plus the rest of the rooms that are unoccupied equals 50. Bam! Makes total sense. All right. How about this one? Owen bought some toy cars at a garage sale. He gave 9 cars to his sister. He had 87 cars left. Which equation, when solved, will tell how many cars Owen bought at the garage sale? Well, I'd add them, wouldn't you? Yeah, 87 plus 9. So that's addition. So I'm looking for subtraction. I got 2 of them here. This guy here, well, 9 minus 87 equals the cars that he bought? No. The C is out by itself there. You can't have that over there in isolation. It has to be with this one. So this one is properly formatted. Let's see if it makes sense. He bought a bunch of cars at the garage sale. He gave 9 to his sister. He has 87 left. Ba-bam. There we go. Let's keep rolling. This is a really tough one. I'll give you a little extra time on this one. There is one like this on the quiz or the chapter test. I can't remember where. The temperature this afternoon went up 10 degrees between 3 and 4. The temperature at 4 was 77 degrees. Which equation, when solved, will determine the temperature at T degrees at 3 p.m.? well, let's see. 3 and 4 o'clock. At 4 o'clock, it was 77. And it went up 10 degrees. So I would go 77 minus 10 degrees. So that's the subtraction to solve it. So I'm thinking addition. There's two addition ones. This one's not formatted correctly, so I'm not even going to look at it. There was a temperature at 3 o'clock. It went up 10 degrees. And it was 77 degrees at 4 o'clock. There we go. Thank you. All right, let's take a look at another one. A couple more here. Linda took some almonds from a bowl. She ate 21 of them and had 16 almonds left. Which equation, when solved, will tell how many almonds Lisa took from the bowl? Well, let's think about that. She ate 21, had 16 left. So I would add those together to get like 37. So I'm thinking if I add, it's got to be a subtraction. So let's take a look at that. Oh, unfortunately, I have a bunch of subtraction ones. This one looks kind of weird. The almonds she took from the bowl minus 21 is equal to 21 minus 16. What? That one makes me dizzy. The almonds she took from the bowl minus the 21 she ate, there were 16 left. Cha-ching! All right, number 10. Give this one a shot. Last weekend, Beth collected red leaves for an art project. On Saturday, she collected 60 leaves, red leaves. On Sunday, she collected some more red leaves in the park. Now Beth has 87 red leaves. Which equation, when solved, will show how many red leaves Beth collected on Sunday? Well, let's think about that. Go ahead. So if she has 87 total and she got 60 on Saturday, you just subtract, right? So I'm thinking addition. I got two addition ones. This one's not formulated properly. Look at it. It's just sitting out there. So let's try this one. 60 red leaves on Saturday plus some more on Sunday. 87 total. Mr. Dudley, you make it look so easy. No, I'm just following the steps. I'm just following the steps, talking myself through it. All right, number 11. Richard picked a bunch of flowers. When he arranged them in 7 vases, each vase had 10 flowers. Which equation, when solved, will tell how many flowers Richard picked? Go ahead and give it a shot. All right, well, I just go 7 times 10. You got 7 vases with 10 flowers in each one. That's 70, right? So that's multiplication, though. So let's look at division. See if that makes sense. Here's the flowers that he picked. He divided them among 7 vases, 10 in each vase. Ding, 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 ding. You're the next contestant on The Price is Right. Sorry, getting a little weird. All right, number 12. The stuffed animals at this toy store are split among 10 shelves. There are 5 stuffed animals on each shelf. Which equation, when solved, will tell how many stuffed animals the store has? All right, think about that. Well, 10 shelves, 5 animals on each. 10 times 5, right? So there's 50 animals. So that's multiplication. So let's look at the division. 10 shelves divided by the total number of animals equals 5. What? No. That doesn't make sense. The total number of stuffed animals divided amongst 10 shelves, 5 per shelf. Bing, bing, bing. Right there. My friends. All right, number 13. Colton bought a bag of jelly beans. He ate 26 of them. He had 59 left. Which equation, when solved, will tell you how many jelly beans are in the bag? Well, wouldn't you add them up? Yeah. So which equation is opposite of adding? Subtraction. Well, these two. So 85 total jelly beans. 85 wasn't even a number. Minus the jelly beans he bought equals 59? I don't think so. Let's try this one. Here's the jelly beans that he bought minus the 26 he ate. There are 59 left over. Ba-bam. All right, number 14. Just 3 left. For a recycling project, each student collected 2 plastic bottles. The students collected 68 bottles in all. Which equation, when solved, will tell how many students participated in this recycling project? Well, 68 divided by 2, right? I think that's 34, but it doesn't even matter what the answer is. Let's just see. That was division, so let's look at multiplication. Oh, shoot, I got 2 of them here. Well, let's see. Oh, I got 3 of them. 68 total bottles times, 68 bottles in all times 2 bottles each student collected equals S? What? No. And the S is off by itself. That doesn't make any sense. Wait a minute. This S is off by itself. That's not formulated properly. That's not going to be right. Let's check this one out here. The number of students, there we go. The number of students times 2 bottles each is 68. So there's my 34. See how helpful it is to actually have the answer to see if it makes sense? You bet. All right, 2 left. Here they are. Jared has 42 sweaters in his closet. Sounds like my wife. He has some sweaters in his dresser as well. Jared has 52 sweaters in all. Which equation, when solved, will show how many sweaters are in Jared's dresser? Go ahead and give it a shot. Yeah, I'd subtract 52 minus 42. He's got 42 in the closet. He's got 10 in the dresser. So I solved it with subtraction. Let's look for addition here. Let's see what we got here. We got addition here. 52 sweaters plus 42 equals what? No, that's not the number of sweaters that were in the dresser. Let's try this one. 42 sweaters in the closet plus the number of sweaters in his dresser equals 52 in all. Ba-bam! There we go. And this one was formulated wrong anyway. All right, last question. Bobby and Alexa found some seashell conchs. Found some seashells on the beach. Bobby found 10 shells altogether. They found 61. Which equation, when solved, will show how many shells Alexa found? Okay, go ahead and think about that one. Well, I guess I'd subtract. I'd go 61 minus 10 to figure out how many Alexa found. So I guess I'm looking for addition. There's only one addition, so let's see if it makes sense. Here's the 10 that Bobby found plus the shells that Alexa found, total of 61. All right, I think you are ready for the quiz. But if you get done with the quiz early, I said I would introduce some challenge problems here, the early finisher challenges. So here are 5 problems right here. I'll let you take a look at them. Just going to pause for a few minutes. Challenge number 1. And here's challenge number 2. These are tough. This is what the kids usually do for their independent study. And then here are the answers to those problems. I'm just going to put myself up in the corner so you can see. I answered them, and I also wrote the equation. That's what you're supposed to do. It says up here. Okay, thanks a lot for listening. Good luck on your quiz. Again, these last ones you don't need to do. These were just challenge problems for those of you who worked quickly and got through the quiz and wanted a little extra.